Hello everyone. So today we're going to talk about chemistry and some core concepts that you need to know to further understand what chemistry is and how it works. First things first, what we need to know is that chemistry studies matter. And not only that, but chemistry studies interactions between matter and the changes it undergoes. So the chemistry is the study then of matter and its changes. But you might be wondering, well, what is matter? What counts as matter? Well, matter is anything that occupies a space and that has mass. And mass, well, you can traditionally see it as something that has weight. Something that gets attracted to the earth, like it could be an apple, for example. An apple occupies space and has mass because you need to apply some force to it to lift it, or maybe a car. It's heavy, it has mass, a lot of mass. So anything that occupies space and has mass is matter, or is made of matter. Then there's some keywords that we need to understand when we talk about chemistry. One of them is substance. So a substance is a form of matter that has uniform properties. For example, you could say a gold ingot is, if you have a gold ingot, let's say that's a gold ingot, it has a uniform set of properties. Maybe water. Water is a substance. Water with salt in it is also a substance because it has a uniform set of properties. Then we could define substance as a form of matter with uniform set of properties. There we go. So, and we'll get a bit deeper into what a substance is when we see the next two. So, what is an element? Before defining what an element is, we need to know what an atom is. An atom is the minimal division of matter. So that's the tiniest division of matter that keeps its own unique properties. It's a minimal division of matter that keeps its own properties. And what do I mean by this? A good way of looking at this is that if I keep cutting and cutting and cutting this gold ingot, I'm essentially going to get to a point in which I'm going to get to something so small that I'm not going to be able to cut, which is an atom right there. Now, this is not an atom of gold. This is an atom of helium, and you can tell by the amount of protons that you have there. But an atom is essentially a unit of mass that keeps its own properties. What do I mean by keeps its own properties? That, for example, with gold is conducts electricity. So if I have an atom of gold, I know that that atom of gold is going to conduct electricity. If I keep dividing that atom, it may not conduct electricity anymore. It may turn into something else. So it lost its properties. If I have an atom of iron, for example, iron is metallic. It has its own properties. If I keep dividing and dividing and dividing that, I'm going to get to an atom of iron. And if I divide that further, it's going to lose all of its properties. It's going to lose the weight that it has. It's going to lose the amount of protons that it has, and so on. So an atom is the minimal division that keeps its own properties. And atoms contain, just as I mentioned, protons, which is tiny particles that have a positive charge. Neutrons, which is this blue one right here, which is another type of tiny particles that have a neutral charge. They don't have any charge. And electrons, which is tiny little particles wandering around the protons and neutrons that have a negative charge. Now let's dive in what an element is. An element is essentially a specific type of atom. Specific type of atom. Or you could see it as an atom with a specific amount of protons with specific properties. For example, let's say an atom of hydrogen. So if I have a bunch of these atoms of hydrogen in a closed space, at room temperature, they're going to be a gas. So that's one property of hydrogen. Another property of hydrogen could be how much temperature you need for it to become a liquid, or several things that are included within what hydrogen is. So an element is a specific type of atom that have a unique property. And how do you distinguish between these unique properties? How do you distinguish between atoms? Well, what between elements? Well, what tells you the difference between elements is just as we see in this periodic table, is the amount of protons that they have. The periodic table is just a set of all of the elements that you have, so each individual one of these is an element, that is a type of atom. And the numbers, I'm going to get close to this, the numbers right here, you can see that the periodic table is arranged horizontally with those numbers increasing, right? 1, 2, 3, 4, and etc. 20, 21, 22. What does that number signify? That number tells you the amount of protons that you have in that specific element. The amount of protons is going to tell you what the properties of that element is, and which element it is. So we know what an element is now. It has unique properties and a specific number of protons. So what is a mixture? A mixture is a conjunction of different elements or different substances. So a substance is just some form of matter that you see. It can be made out of any element that you have, right? It can be made out of sodium with potassium, or sodium with anything, and you can have like a bunch of elements that are making out this substance. And this substance is just a specific amount of mass that you have, or in a specific form, right? And that has its properties. So a mixture is just a conjunction of substances. It doesn't necessarily need to be a conjunction of two elements, or three, or more. It's definitely going to have elements in it, because it has atoms, and anything that has atoms definitely has elements, because elements are just specific types of atoms, right? Now, here's what happens with this. A mixture, for example, let's say, could be homogeneous in the case when we have water and we decide to put in some salt in it. That's salt. So if I go ahead and stir that salt, that's a spoon, let's say, if I stir it in the water, it's going to dissolve and it's going to turn into a homogeneous mixture. So a homogeneous mixture is a mixture that is uniform thoroughly. What does that mean? Well, that means you cannot tell where the division of the substances that you have in that mixture is. Once you dissolve that salt, you cannot tell where is the salt. You know it's within the water, it's mixed with the water, but you cannot tell the difference with the naked eye between what is water and what is salt. So that's a homogeneous mixture. And a heterogeneous mixture is just not uniform. What that means is that you can tell with the naked eye what the components of it are. Let's say, for example, a salad could be a mixture that is heterogeneous, like this. Let's say we have lettuce, or for example, tomatoes. So those are all substances, let's say, that are being mixed in a salad. And you can tell by the naked eye, oh, that's a tomato. Oh, that thing is a lettuce. Or, oh, that thing is whatever. So you can tell them apart with the naked eye. They are mixed, but heterogeneously. It's not a uniform mixture like this one in the salt and water. You cannot tell, when you dissolve the salt, you cannot tell the difference between where is salt and where is the water. That's homogeneous. We can also note there that a substance then can be a set of elements, can be a set of elements, or a set of mixtures. An element is a simpler substance than a mixture, because a mixture has more elements with it.